Hello, my name is Nishan Chatterjee, and today we're going to look at the LeetCode problem majority element. We're going to look at the problem description and give an example. Then we're going to look at three solutions: the bit manipulation solution, the sorting solution, and the Boyer-Muir voting solution. For each solution, we're going to give an example, an explanation of the solution, give the code, and analyze the time complexity. Now let's look at the problem statement. You're given an array, and you're supposed to find the majority element. The majority element is defined as the element that appears more than n divided by 2 times, where n is the length of the array. You can assume that there's only one majority element. So in this example here, you are given 3, 2, and 3. The length of the array is 3, and 3 divided by 2 is 1 if you round down. So the solution would be the element that appears more than one time. We see in this example that 3 appears more than one time, so 3 is the solution. Let's first look at the bit manipulation solution. We know that if we just count the bits, the bit that appears the most times for each number, then we can construct the answer using the most frequent bit. We first look at the 0th index, check which bit is the most frequent. Then we look at the first index, check which bit is most significant, and we continue like that until we have checked all the indices, and while we find the most significant bit, we construct our answer. Let's look at an example. We are given 3, 2, and 3 again as the input, and on the left we have these two squares which resemble the bits of our answer. We're given that 3 is bits 1 and 1, 2 is bits 1 and 0, and 3 again is bits 1 and 1. We first look at the 0th index, and the most frequent bit is 1. So we set 1 as the 0th index in our answer. Then we look at the first index. The most frequent bit is 1, so we set 1 as the second bit. Our result is a binary number 1, 1, or 3, and we see that 3 is the correct answer. We can easily check the most frequent bit by counting the number of 1s and counting the number of 0s and checking which one is greater. Let's look at the code. We have the driver method. Then we set a result variable equal to 0. So every bit in this number is 0. Then we iterate over all 31 bits, and for each bit index, we iterate over the array and increment the zeros if the bit is equal to 0. Otherwise, we increment the 1s. Then we check if the 1s is greater than the zeros, which is when we set the result bit at that location equal to 1. Otherwise, we don't have to do anything because the default bit of all the bits is 0. Then we return the result at the end. The time complexity should be O of n because the array is looped 32 times, and each time we iterate over the array once. So the time complexity is O of 32n, which is equal to O of n. Now let's look at the sorting solution. All we have to do for this solution is sort the array and return the array at n divided by 2 index. Let's see how this works. We're first going to look at an odd length array. The length of this array is 7. So 7 divided by 2 is 3. So the majority element has to appear 4 or more times, which is greater than 3. And once we sort the array, all the majority elements are in consecutive indices. Even if the majority element starts at the leftmost index, it covers 4 indices, and if it's at the rightmost index, covers all of these indices. N divided by 2, which is 7 divided by 2, should be at index 3, and we see both of these locations will get the majority element at index 3. Now let's look at an even length array. The length of this array is 6, and 6 divided by 2 is 3, so the answer, the majority element, should appear 4 or more times. If we start from the beginning, we cover 0 to 4, and we see that index 3, which is 6 divided by 2, is covered. If we go from the end, index 6 divided by 2, which is 3, is also covered. The code is super simple. All we do is sort the array and return nums at nums.length divided by 2. The time complexity is just O of n log n, since we sort the array and do nothing else. And sorting is n log n. Now let's look at the Boyer-Muir voting solution. This is a complicated solution. What we do is iterate over the array, and for each element, we have this count. We initially have this count element, a variable, and a candidate variable. The count is initially set to 0, and the candidate variable can be initially set to whatever. For each element, we first check if the count is 0. If it is, then we set the current number as the candidate. Then we check if the candidate is equal to the current element. If it is, then we increment the count variable. If it isn't, then we decrement the count variable. Let's look at an example to see how this works. So first, the candidate is nothing, since we haven't started yet, and the count is 0. We look at 2. The count is equal to 0, so we set the candidate as 2. Also, we increment the count because 2 is equal to the candidate, which is what you just set. Then we look at 2 again. It is equal to the count, so we increment the count. Now we reach 1, and since it isn't equal to the candidate, we decrement the count. We do the same for the next one, and now the count is equal to 0. So once we reach 1 again, we set the candidate equal to 1 and increment the count again. Now we reach 2, which is when the count is set back to 0. And when we reach the last 2, the count is equal to 1 and the candidate is 2. The candidate we have at the end is our answer. We see in this example, 2 is the correct answer. This algorithm works because we know that the majority element appears in over half the elements. So even if every other element is different and decrements the count, the majority element will still keep the count above 0 because it appears more times than any other number. Let's look at the code. We have this driver method. We initialize the count and the candidate to 0. The candidate can be 0 or anything because we set it in the first iteration anyways. Now we iterate over every num. If the count is 0, set candidate equal to the num. Otherwise, we check if the number is equal to the candidate and increment the count. Otherwise, we decrement the count. Outside of the loop, we return the candidate. The time complexity is O of n, since you iterate over the array and do nothing else. Thank you for listening, and I hope you enjoyed.